All right, welcome. This is the February 6th, 2024 P4.org Open Source Developer Days meeting. We have a guest speaker today, Panos, and I will let him introduce himself. Please take it away.
Hello, everyone. First of all, thank you for having me. I'm Panagiotis Famelis. I work in Ubitech. It's a software house mainly involved in research projects. Today, I would like to present to you TeraFlowSDN, which is a cloud-native controller, also for P4, not only for P4. So yeah, let's dive in. So first of all, the agenda. I'm going to have a brief introduction to TeraFlowSDN, how it came into being, what is our purpose, etc. And then I'm going to go over a little bit about the architecture and abstractions we provide, mainly the three levels: device level, service level, and management level. I'm going to show you a short demo. It's a video, I think it's 4 minutes or something like that, of basically what I've described before. And finally, I'm going to close with the future developments we plan to have in the following months, and yeah, a call if you want to contribute. So what is TeraFlowSDN? So basically, TeraFlowSDN, it's an open source community. We have the ambition to create a cloud native smart SDN controller. It was created in May 2022. It began, first of all, as an European Union Horizon 2020 project that was called TeraFlow. And after that project ended, we went under the umbrella of ETSI and created this open source community. The idea is that we want to have to support a large set of use cases and also enable various ETSI groups like the NFV, the microwave transmission, OSM, etc. And also this endeavor that began in the project TeraFlow and continued in TeraFlowSDN, it continues now in the next batch, let's say, of European projects under the umbrella of 6GFNS. And you can see on the right side some of these projects. Also, just to know that I will send this presentation afterwards to the mailing list so that you can have it. So the question that everybody asks is, do we need yet another SDN controller? The answer to that question is why we may need such an SDN controller. And when we began working on TeraFlow, we wanted to create a cloud-native SDN controller to leverage the microservice architectures and have all those benefits that provides us, like scalability, self-healing, integrity, etc. And also we wanted it, basically TeraFlow, to be a toolbox for, first of all, for edge groups to work on it, but also to provide and support use cases across many different and multi-SDO environment that we are now. And of course, our purpose and our idea is to produce that controller as an open source code under the Apache software license. TeraFlowSDN began, as I've said before, from the project. We're a growing community. These are some of the partners that are actually developing and are actually contributing. And of course, everyone is welcome to contribute and participate in the various meetings. I have here some of the published publications we made in the past in various conferences. Of course, these are just some, just to showcase. For example, we have on OFC the first paper, which was proof of concept to showcase mainly what we can do with TeraFlow. We also have this anomaly detector and anomaly mitigation that had to do more with the optical part. On ECOC, we presented how we can integrate with open source Mano, OSM, HOSM, and produce inter data center connections, leveraging both OSM for the NFVs and TeraFlow for the network. On IEEE NFV-SDN, we presented how we could use TeraFlowSDN as an underlayer to have some distributed ledgers. And on IEEE HPSR, we presented how we can use TeraFlowSDN to, first of all, control P4 devices and also apply some policy and some traffic engineering, let's say, not really, but close to it, on them. The last one, is basically what I'm going to also show you today here. Some general information, you can find the repository on the GitLab. Here you can also have the link. We currently we plan to release every 6 months. This was not done so in the past. We had a little hiatus of about 10 months that we hadn't released. But in any case, now we're in release 2.1. And we are just before release 3. Basically, we have a code freeze on the 12th of February, so on Monday. And we plan to have the release 3 by the end of the month, by end of February. So moving on to maybe more interesting stuff on the architecture and abstractions. This is a graphic we usually use when we want to show HDFS. And basically on the bottom we have the infrastructure. It could be different things, as I will show you in a bit. And then we have all those boxes that basically are different components. From those different components, some of them are considered, let's say, core, in the sense that they provide services and functionality that they should exist for TeraFlowSDN to work, and other are more like applications in the general SDN nomenclature. So what is infrastructure, basically? We aspire to be able to control many different devices and in different domains. We want to have TeraFlowSDN expand from the front hall to mid-hall and backhaul, and also in the data center. So for that, we also support many different kind of technologies from OpenConfig, IETF, P4, TAPI, etc. In this talk, I'm going to talk about mainly 4 different components. The SBI, the southbound interface, the service, the policy, and the monitoring. On the SBI, just before moving on, the approach we use is that we have this device service, which is communicating through gRPC with the other components. And then we have this SBI driver API. This is an abstract API, an interface, let's say. And we have different drivers that can implement this API in order to be able to communicate and control different kind of devices. So this is not extensive. There are more drivers that we have already implemented. But for example, here we can show OpenConfig before Transport API, IETF, ONF, and XR driver. Of course, we have more, and we plan to implement more in the future. We also have the service, and on the service, I'm going to explain a little bit more what exactly we mean by service and how it serves us. But also here, we follow a same approach. We have this service, let's say, that communicates through gRPC with the other components. And we have different service handlers. So we have layer 2 and layer 3 for GNMI, for OpenConfig, IETF layer 2 VPN, microwave data links, before optical TAPI, etc. And finally, we have these 2 more components: monitoring and policy. This is the core that I'm going to touch in this presentation. And basically, from these 4 components, we try to see what kind of abstractions we provide. So let's begin with a simple case. We have a switch, and we have 2 hosts that are connected to the switch. And we want to have some way of TeraFlowSDN to be able to communicate with that switch and also configure it to enable this communication. So here for P4, for example, we have the configuration protocol of P4 runtime, and we use some kind of P4 rule. This is stuff that most probably is known. We have some table that we are going to insert the rule to. We have some header fields that we're going to match with, and some action that we want to do if that rule matches. Okay, until now, it's something that it is I most probably is pretty clear and understandable. However, managing a single device is usually not a problem. What we usually want to do is manage larger topologies or even real networks which can span over different kind of segments, different kinds of technologies, etc. For that reason, we need to define these abstractions of connectivity from one endpoint to another, irrespective of what is in the middle. For that, we propose this service level abstraction using the service component. What we have here is basically that before in the SBI, we just enter input a rule that is given on the device and it is configured. For the service, on the other hand, we give it two endpoints. And then we have another component, which is this path computation component, which undertakes the work of finding a good path between these two endpoints. Okay, and then this service component, after it has computed, it has decided what path it can take through the network, it goes to the SBI and configures its device that is part of this path. The important part here, and the one that I think it's really interesting, is that we can also support heterogeneous, let's say, devices. So we can support sub-services, so a service that comes from endpoint 1 to endpoint 2, and under it there is some sub-service in the middle that is just for P4 device, for example, or for devices that talk to OpenConfig. How do we do that? Well, we have this kind of configuration. We first of all define what type of service this is, and this corresponds to the service handlers I've showed you before. And then we have the endpoints ID. So basically, we defined from one endpoint, in this case, switch 1, port 1, to another endpoint, switch 5, port 3. And then we also have this optional service configuration, and this is something that is handled per service handler. So you could have here either constraints or configurations that you as an operator can enter when you define the service, and the service handler should do something with that. For example, you could say that I want to exclude some specific switch, or that I want to put a cap on how many hops we will have for this service, etc. But even that, while it provides really good abstraction and the ability to configure, let's say, your services on a network-wide perspective, and also it hides the complexity of the device layer. However, it also is not enough in the sense that we need some way to trigger these service APIs in an automated fashion, basically to reconfigure services based on the reconfigurations that may happen on the network. And how can we achieve this? Our answer to that is through what we call these management level abstractions. And first of all, what we need in order to have any automation is observability, is some kind of monitoring. For that, we have this monitoring component, which communicates through some monitoring protocol to either a device or even a service. And we register, and it collects KPI values, and we can through that monitor the status of the network. We also need this extra component of policy, which what it does, it's basically, as the operator defines a service, they can also define a certain policy, basically a service level agreement that defines what kind of constraints and what kind of real-time KPIs should be adhered to. The way this policy is defined is, first of all, we map the service unique ID. We map the service to the SLA through the service unique ID. And second, we have this condition list, which defines when this policy should be triggered. So for what I'm describing now, policy is basically a condition action mechanism. And also, if we have multiple conditions, we can have different Boolean operators, so basically and or. And also, we then have an action list, which specifies what kind of actions need to be executed when this trigger happens. So how does that work? It's basically that when a policy is registered to the policy component, that policy requests from the monitoring some KPIs to be monitored. And when something happens, for example, a threshold is passed or something like that, the monitor component throws an alarm to policy. When that happens, policy triggers the actions that are already defined and sends them to the service. For example, we can have here a path recomputation, as it will be shown in the video later. And after that happens, service then cascades the effect to the lower levels and basically reconfigures the various devices. So in summary, we have these three levels of abstractions, device level microservices, which can handle heterogeneous data planes. And we can create here device specific and protocol specific configuration. We have this service level of microservices, which define end-to-end connectivity between two endpoints. And also we have this idea of subservices that can span over multiple segments of the network. And they take us from devices, from devices to the whole network, basically. And we offer path computation as a service in the sense that also path computation module component is modular, and we can have different algorithms that could be run there. And finally, we have this management level microservices that to get all the above together with monitoring policy, they close a loop, and they are able to auto-update to enforce specific SLAs upon network state changes. So let me go here on the video. So this is the topology that we will be talking about. You can see that it has three branches, basically. It is a simple redundant topology, but it's just a proof concept to show you what we're doing. So after that, first of all, we have the definition file for the devices. You can see here that we have different configuration. For example, the IP address of the device, the port that it listens to, the P4 program that we are going to program on it. And also we have the topology. So basically the links that exist. Currently, this is done manually. Let's say this is done through this configuration file. But in some protocols, we also have automatically finding what kind of links there exist. Not in the P4 driver, we don't have that, but it is something that we eventually would like to see how to implement. But in any case, here we have the various links, and also here in the end, we have the definition of the service, where you can see that we want a service from switch 1 endpoint 3, so 4 basically, and switch 8 port 4. After that, we run a script in order to register the devices to TeraFlowSDN. And we can see in the web UI here that the devices are onboarded. So you can see that we have the 8 switches. And we can see the various parameters that were defined before. Also, the same goes for links. Now we're setting up the monitoring agents. This is not really TeraFlow related, but in this case, we just run some ping and we tie the KPI to the service. So we need to know the latency that we have from one endpoint to the other. And and you can see that at this point, we still have no service. So the ping returns -1, which means that it doesn't have any connectivity. On the right side, we run a create service. So we requested from TeraFlowSDN to create this service from one endpoint to the other. And you can see here that it received this create event and it tied this KPI with the service. And we can see here that we have connectivity. The same can be seen on the web UI. And we can see that this service has the path computation component has decided that it should take the path from switch 1 to switch 6, 7, and finally to 8. And in Grafana, we can see the monitoring, how it goes. And we can see that no policy is set currently. Next step is to next step is to set the policy. As we have said, we need to match the policy to the service. So we are copying here context UID and service UID. And you can see that we have as action we have recalculate path, and as condition list we have greater than 10,000. This is in microseconds, which basically means 10 milliseconds. And now we can see here that the policy is provisioned. That means that as I said before, the monitoring, the KPIs have been set on monitoring, and policy has requested for alarms if it passes some specific threshold. Now, as I've said before, we can see that the path now contains switch 6. So we're going to go on mininet here and enter some delay using traffic control. And we can see here the delay. Basically, we see that it went over the threshold, and we see that the policy state moved to enforced. And we will see here that after a little time, the service returns under the threshold. And we can also validate this by seeing the new path. If we refresh here, we see that the new path is through switch 4 and switch 5. So switch 6 does not is not in the path. So this is the short demo. Yes. And now going to the last part about future developments. First of all, relate to the demo I have shown you. This will not, all of these that I'm going to say are not going to be in release 3, the next release, but we are confident that some of, if not all of them, will be in release 4. So first of all, we plan to have a restructuring of the monitoring component in order to facilitate better telemetry functionalities and also to unbundle the analytics functionalities from it. So now we have just an alarm system that works with threshold, but we want to have some better analytics, maybe using some statistical methods. And in the future, we could also try and see if we can have some AI on it. Also, we plan to have a new automation component that will be aligned with the HCZSM loop in order to manage, monitor, and configure this closed loop, like the one that I've described with policy. So we want here to provide both a front end on creating this closed loop much more easier, but also provide a framework on how we can have different closed loops and how they can interdepend on each other. This is related to TeraFlow. Now, related to P4, well, first of all, the SBI driver supports most of the features of P4 runtime. We are using the P4 runtime specification, the Python library, and most probably we support all the features that it supports. However, the service driver for the P4 as it is right now, it is quite limited. Basically, it works with just one program in the sense that it needs to have a specific table and specific fields on it. Basically, it does a layer 1 port-to-port forwarding. However, this can be extended and will be extended to enable more use cases. Our idea here is, first of all, to enable table agnostic, basically, services. So when an operator requests a service, they have to also define what kind of tables exist in their P4 programs. This is the first step. And the second step is we're investigating integration with the Sonic software suites and more importantly, the PINS, so that we can actually use both P4 for the data plane and GNMI for the management plane. We want to go that route because that could also enable us to have some information that is not really obtainable using P4 runtime. For example, what kind of ports we have, how many, etc. So we believe that after we are finishing with this integration with the Sonic software suites, maybe it will be easier to enrich further the service handler for P4. And finally, we also plan, this is in parallel, we also plan to implement in-band telemetry, INT, as part of both the service, the SBI plugin and the monitoring system. This is in order of maturity, basically. So the first abstraction of service P4 service driver is something that it is almost mature to be a merge request, while we are currently in the process of investigating the integration with the Sonic software suites, and then we want to see how we can implement in-band telemetry. This was mostly about the what I want to present to you. Also, just to know, we have these community get-togethers every 6 months. We call them the TeraFlowSDN Hackfest. The first one was in Madrid, collocated with the Network X exhibition and the 13th RSM Hackfest. The subject was in general about TFS, but also we had the dedicated P4 presentation. The second one was in Madrid. We didn't have any P4 there, but it was mainly about OpenConfig and GNMI. However, the third one was in Barcelona, and there it was fully dedicated to P4. You can find the videos from this session in YouTube. And we usually have a collocated ecosystem day and plenary meeting so that individual or projects can showcase their work. And we have plenary meetings to design further developments. Also, this is something that has not been announced yet. So this is the first time of announcement. The next Hackfest will be in Athens, in Greece, on the 21st and 22nd of May. Unfortunately, most probably there will not be something regarding P4. However, we can see if there is interest in that. Finally, if you liked what you saw and want to see more of TeraFlowSDN, feel free to join us. Participation is open to HC members, non-members, individuals, and users. And it's free of charge to participate in the design process and the government of the project for HC members, SMEs and MEs, universities, public research, user trade associations, and individuals. You can learn how to join on the website or you can contact TFS support at etsy.org. And of course, feel free to join us on Slack and have any question or discussion about TeraFlow. Thank you very much. I'm open to any questions or comments.
Thanks, Panos. I had my first question would be so that the TeraFlowSDN project is new to me with your talk, so thanks for the introduction. I was curious, what is the project hoping to be deployed someday in, production telecom operator networks or commercial networks? Is that its goal, or is that part of its aspirations?
Yes. Let me go back, sorry, to the participants, because we have Telefonica. Telefonica is a big operator in Spain, and they are actually using TeraFlowSDN in some parts. I'm not sure in what extent. It's not about P4. I think that it is, if I'm not mistaken, no, let me not say it because I'm not sure. But yes, our purpose is to build an SDN controller that is resilient enough to be used in production.
Okay. I'll let the floor open for anybody else who has any questions. I'm mentally counting to 7 seconds there to give everybody time. I didn't see any hands raised. Sorry if I missed it, but let me check chat real quick. Another question I had was, so you say, when you say cloud-based, it wasn't, does that mean, so for example, are the software components of TeraFlowSDN intended to run on a service like AWS or Google Cloud Platform or Microsoft Azure, or do you mean a private cloud or both?
Yes, basically we are deploying on Kubernetes. So it could be deployed on public clouds, private clouds. I'm not sure about both because I'm not sure about the connection, but yes. The idea is that we want to be able to deploy on Kubernetes on cloud native, basically.
Okay. And I imagine, like, for example, a telecom operator, they might want to, I would imagine they would run it on their own private cloud. They would not want to run that on somebody else's infrastructure. It was my guess, just for security and operational reasons, I would guess. Okay, thanks. We do have a question. How can we get the slides? I think you said you would email those out to the P4 email list, a link to those after the meeting. So yeah, you should be able to get. I will, when I figure out how, I will publish the recording. But then you can also publish the link to the slides. Any other questions for Panos? Okay, well, thanks.
Thank you very much.
Speaking, really appreciate it. I'm going to stop the recording now.
Okay.
If I can figure out, oh, there we go. I figured out how.